Hi, it's Ross from STS. Welcome back to the channel and video number 93. Today I'll be discussing Aero engines, diesel versus spark ignition. We'll be comparing some specifications, weight, power, fuel economy, brake-specific fuel consumption, and some operating costs as far as fuel burn. And we'll see some information on the new Adept 320T engine from South Africa. It's the first clean sheet Aero engine design for a long time. Adept Air Motive was very helpful when I contacted them for information. They sent me some extra photos, some more specifications and details not shown on their website. So we're going to have a little more information on that engine than some of the other engines. Unfortunately, when I contacted Continental Motors asking for permission to use some of the photographs off their website, they didn't even bother answering, which was unfortunate. I will still give them some good airtime here and discuss their engines without the use of those photos. Continental Motors has really done a fine job progressing some of the earlier diesel designs, which had a lot of problems. They put a lot of engineering and money behind fixing these problems, and I think they've got some really good offerings in the diesel market now. Too bad we couldn't have used those photos in this video today. It would have made for a nicer video.
So we'll be comparing some common engines that most people are familiar with here, various Lycoming engines and Continental engines, and then the diesels, which you may be a little less familiar with. So we've got the Continental CD155, which is a 2-liter geared inline 4-cylinder engine, aluminum block based on the T-Lert 1.7, which in turn is based on a Mercedes automotive liquid-cooled diesel. Continental CD265, which is a 5-liter direct drive opposed 4-cylinder engine based on the French SMA 305 clean sheet Aero diesel design, and it's air-cooled. The Continental CD300, which is a 3-liter geared V6 engine based on a Mercedes automotive engine again, and it's liquid-cooled. The Austro AE330 engine, again, 2-liter geared inline 4 with a cast iron block based on the same automotive Mercedes diesel engine as the CD155, and it's liquid cooled, of course. And finally, we've got the Adept Air Motive 320T. It's a 3.2-liter geared V6 spark ignition engine, clean sheet design from South Africa, liquid cooled, of course. This innovative engine has been under development for around 10 years, and company officials tell me production is right around the corner now. As I said in the introduction, Adept was kind enough to share some additional information with me, and I think you'll be impressed. This engine has some pretty impressive brake-specific fuel consumption, power-to-weight ratios compared to legacy air-cooled aviation engines. A lot of the fuel consumption data was taken from this paper for the Continental and Lycoming engines. For the other engines, that came from the manufacturer, or in the case of some of the modified engines, our best estimate based on some flight test data. Okay, we've got our engine comparison chart here, and this is the engine types we'll be comparing. So we got carbureted 0360 Lycoming, mechanically injected 360, EFI equipped 360 with high compression, carbureted 540, EFI 540, and standard IO 540 from Lycoming with mechanical injection, turbocharged 540, normally aspirated Continental IO 550, turbocharged 550, and these are the diesels here, the CD155, CD265, CD300, the Austro AE330, and the Adept Air Motive 320T. So in this column we've got horsepower. That's pretty self-explanatory. And this column is dry weight in pounds. We tried to get the most accurate figures we could from the manufacturer or other trusted sources. And this is the horsepower to weight ratio. This is horsepower divided by the weight in pounds. This is specific output. So this is in horsepower per cubic inch. This is a compression ratio, pretty self-explanatory. And this is the brake-specific fuel consumption at takeoff power, brake-specific fuel consumption in cruise, and type of cooling use for the engine, air or water cooled, and the drive, whether it's direct drive or geared. So what can we see from this chart? Well, the traditional air-cooled direct drive engines have a fairly low weight. The turbo engines, of course, weigh quite a bit more. The diesel engines, the CD155 in particular, is very weight competitive with something like the 360 Lycomings. It's right in between the parallel valve and the angle valve injected engine. The CD265, which is a direct drive air-cooled diesel, is reasonably weight competitive with the, say, equivalent Lycoming parallel valve 540. A little bit heavier, but not bad. The CD300, 548 pounds versus the IO540. It's about 100 pounds heavier, roughly the same horsepower. So that's quite a weight penalty there. And then the Spark Ignition Adept 320T, which is a turbocharged and geared engine. Very low weight for the horsepower. Pretty well beats anything on this chart, which is to be expected. You can see horsepower per weight. The air-cooled direct drive engines fairly low. Even the CD155, which is fairly light by comparison, horsepower per weight isn't very good. It's lower than any of the direct drive air-cooled Spark Ignition engines. And CD265 is a little bit lighter for the power, just because it's direct drive, doesn't have a gearbox. And the CD300, pretty much the same as the CD155. The Austro AE330 is a cast iron block, and you see it's quite heavy for the horsepower. It's got the lowest horsepower to weight ratio. And the Adept 320T is geared, high RPM, Spark Ignition, turbocharged. Easily beats anything else on this chart by quite a bit. So for specific output, and that's horsepower per cubic inch, we see here the turbocharged engines, especially the geared ones, do quite well. They're running very high boost pressure compared to the Spark Ignition turbo engines. But CD155 double and almost triple the specific output of some of the Spark Ignition air-cooled direct drive engines. The CD265, you can see how much the direct drive hurts the specific horsepower output. It's much lower than the CD155 or CD300, which are geared engines. And the AE330 is pretty good as well. Of course, the Adept 320 being Spark Ignition, even though it's running much lower boost pressure, again beats all of these other engines in specific horsepower per cubic inch. And next on the chart is the compression ratio. You'll see the older Lycoming engines run fairly low compression ratio. That hurts the horsepower as well as the brake-specific fuel consumption somewhat. Our Special 360 is an EFI-equipped engine with compression raised to 10-to-1. And those two things make quite a difference in reducing the brake-specific fuel consumption. This EFI 540 here is also slightly higher compression, which helps a bit. And you'll notice the diesel engines, of course, much higher compression ratios. That's a necessity of diesels. And the Spark Ignition turbo engines have lowered compression, which hurts their brake-specific fuel consumption even more. So here we get to the efficiency part, brake-specific fuel consumption, and this is in pounds per horsepower per hour, which is the most understandable features to us in North America at least. And the air-cooled direct drive engines, they need a lot of fuel for cooling to keep the cylinder head temperatures in check. So they burn quite a bit of fuel at takeoff power. And if we look at the brake-specific on the air-cooled direct drive turbocharged engines here and here, they're pretty high. They're just pouring the fuel in to keep these things cool at takeoff power. And if we look at the diesels, the big advantage of the diesel, they don't need to be run rich to stay cool. Even the air-cooled CD265, they just don't need to run rich like the Spark Ignition engine. So their fuel consumption at high power settings is much better than most of them. You can see they're all about the same here, very good. The Adept, again, very high specific output. Piston crowns are under a lot more stress with a high revving turbocharged spark ignition engine. They do have to throw some more fuel at it, so it doesn't match the diesels either at takeoff power. And here we've got the brake-specific fuel consumption in cruise, and in all cases here, the engines are being run lean of peak here. It makes quite a difference in the fuel consumption, and of course this can only be done on the air-cooled direct drive engines at cruise power. Running them lean makes the CHTs drop, and of course also the power, but overall we can get quite a bit better economy. You can see the modified high compression EFI 360 does very good numbers here. And this is Dave Anders' engine, very efficient. The traditional carbureted engines don't do quite as good, as you can see here and here, compared to the mechanically injected engines. And the EFI 540 engine with higher compression does reasonably well, kind of splits the difference between the Dave Anders engine and the traditional mechanically injected engines. So the turbocharged Lycoming 540 doesn't do very well, even running lean of peak. These numbers were pulled from that FAA fuel study. I don't know how accurate they are. This seems really excessive to me, but I published this nonetheless because I don't have any other good information to use here. The Continental IO 550 in stock form, despite its relatively low compression, very good brake-specific fuel consumption, and they're kind of renowned for that, running lean of peak. And the diesels do even better than they do at takeoff power, but they're really no better, and in some cases not as good as the modified Lycoming here. A lot of people might be surprised at that, but they could watch my previous video. The auto cycle is actually more efficient than the diesel cycle. And when we get the compression ratios up on the spark ignition engine and equip them with EFI, where we get very balanced fuel and run them lean of peak, they can match or exceed what the diesel can do in cruise. And that may surprise a few people. And the Austro engine seems to perform a little bit better than its cousin, the CD155. It's got matches the lowest specific fuel consumption in cruise with the Adept 320. And moving on to the Adept 320, again, people might be surprised. These figures are taken right from the dyno chart where they're testing fuel consumption and horsepower, and it matches the very best that the diesel can do here. The Adept engine has a very large bore, short stroke design. A lot of people will think that's bad for specific fuel consumption. However, on turbo engines, increased bore size reduces the pumping losses due to the blowdown effect. The work of the turbo compressor pushes down on the piston during the intake stroke and reduces the pumping losses considerably. And as we get down to the cooling, well, we just list whether the engines are air or liquid cooled. So you can do a comparison there. And the drive type. Most of these are direct drive engines unless we get into the 3 of the diesels here, which are geared. And same with the Adept engine. So the gearing allows basically higher RPM, higher specific output, and sometimes, as we can see here, better power to weight ratios. So the increased power is offset by the weight of the gearbox to some degree. Although the Adept has the highest specific output and the best power to weight ratio of all the engines here, being spark ignition, geared, and turbocharged. So this next chart is looking at mission fuel burn for the 4-cylinder engines. And I've thrown my Subaru EJ22 Turbo in here just for some interest's sake. Again, engine type, we've got the standard IO 360 Lycoming, the high compression EFI 360 Lycoming of Dave Anders, Continental CD155, and Subaru EJ22. So we're looking at fuel consumption here for startup and taxi. We allow 10 minutes for that. Takeoff and climb from sea level to 10,000 feet. I will say 1,000 feet a minute, 10 minutes at 140 horsepower average. Then cruise for 3 hours, lean of peak for the spark ignition engines, except for the Subaru. And the diesel doesn't need to run lean of peak. Then we have a descent to destination, 20 minutes at 500 feet a minute. Then we have the total emission fuel burn in pounds. And note that the diesel or Jet A fuel weighs roughly 10% more than the avgas. Then total emission fuel burn in gallons. And then fuel costs. So this was compiled back in September. I checked the U.S. fuel costs for 100 low lead, Jet A, and MoGas, premium MoGas. So if we look at the figures here, a diesel wins hands down on the startup and taxi. It's much more efficient because there's no throttle on it. Takeoff and climb, again, easily wins. Doesn't need to run rich like the other three spark ignition engines. Cruise figures, it's matched by the high compression EFI 360. Still quite a bit better than the standard Lycoming and way better than the Subaru. Then we've got the descent phase here, throttled back. Diesel doesn't do quite as well as you might expect. The diesel has to maintain fairly high manifold pressure compared to the normally aspirated or turbocharged spark ignition engines, but it still beats them here. Total emission fuel burn in pounds, the diesel wins again, not by a whole bunch over the special 360, but by quite a bit over the standard IO 360 and a lot over the Subaru. And total emission fuel burn gallon, diesel kills them all here. Fuel costs, again, the diesel wins handily, burning Jet A against 100 low lead. The Subaru actually beats it on the running the MoGas because the MoGas is so cheap. Then if we compare MoGas, running MoGas in the Lycomings here versus diesel in the diesel engine, the diesel just kills again. And overall, running the diesel on diesel is far cheaper than any of these other engines. And here we've got the six-cylinder engines compared. Same sort of chart here. We assume a bit more horsepower on these. Climb power 266 horsepower, and the cruise 195, and the descent 104. And got the EFI Lycoming here, high compression, Continental IO 550, turbocharged 540 Lycoming, turbocharged 550 Continental, and the diesel CD 300 and the Adept 320. So what do we see here in this? Again, the diesel wins this startup taxi. It also wins on the climb compared to the traditional engines. So the climb to 10,000 feet, the Adept actually beats the diesel, which might surprise people. The Adept is very efficient at the lower power settings with EFI. It doesn't need to run rich to produce this sort of power because it's rated at 320 horsepower normally. The diesel easily beats the two turbocharged engines here. Burns less than half of what the turbocharged 540 Lycoming does in the climb. Obviously, this engine requires an awful lot of fuel to stay cool. It also beats the normally aspirated ones, even the modified 540 and the very efficient IO 550. In cruise, the Adept again wins this one, beats the diesel by a bit, beats the turbocharged traditional direct drive air-cooled engines substantially here, and even beats these two engines, which are quite efficient in cruise, running lean of peak. In the descent, the Adept is again the winner by a small margin. And again, the two turbocharged air-cooled direct drive engines burn quite a bit more fuel than the CD300 in the descent. And total emission fuel burn, this is in pounds, of course. The Continental certainly blows away the turbocharged air-cooled engines by a huge margin here. And even the pretty efficient, normally aspirated six-cylinder air-cooled engines. However, the Adept 320T again burns less fuel for the overall mission than the CD300. Total mission fuel burn in gallons. The Adept wins by a small margin over the CD300. Of course, the avgas is about 10% lighter than the diesel fuel, but the diesel certainly burns far less fuel in gallons than, say, the turbocharged Lycoming. Fuel costs based on the same figures as before. $4.56 for 100 low lead and $4.06 for Jet A. The Continental wins that contest overall. Jet A is just way cheaper than the 100 low lead, and despite the lower fuel burn of the Adept, cost for the whole mission is less with the diesel. And interestingly, it's half the cost of the turbocharged Lycoming in the full mission. So we can see the Adept engine with all the latest spark ignition technology is actually very competitive with the diesel. A lot of people might not believe this. I'm basing these figures on actual dyno testing until we get some airplanes actually equipped with this engine and see. This may not turn out to be true, but so far based on the dyno numbers, where we can look at the brake-specific fuel consumption at different horsepower levels, the Adept does very well against the diesel. And price-wise, the Adept will come in at about $85,000. The CD300 is a brand new engine. No price has been released at the time this video was made. I suspect it will cost more than the Adept. The CD300 is a certified engine in Europe right now, and FAA certification is expected shortly. The Adept hasn't received certification yet. I think they're going to try to raise some money first before they attempt that. Right now it's available for experimentals. So it's nice to see some new technology coming along on the spark ignition side as well as the diesel side. Kudos to Adept for persevering. It's been a long, hard development period for them. Looks like they're finally getting close to production. They've got some partners in the United States finally. And kudos to Continental as well. They've picked up some of the European designs, fixed a lot of the problems, as I said before, and improved them. And they seem pretty solid now. They've got a lot of good engineering. They've got some money to properly develop these things. And I think both spark ignition and compression ignition engines have a good future ahead. So the acquisition costs may not be cheap, but the operating costs, as we've seen in these charts here, can be substantially lower on these new technology engines, assuming they are reliable, of course. And that's something we don't know and won't know until a few years down the road. Anyway, thanks very much for watching. I hope you found it interesting, and we'll see you in the next video.